Okay, so now let's move on after discussing the project ideas. So let's move on to the new lesson we're starting today. But before that, we can go check some of the information you guys learned in the previous lesson. Just let me get the book, the textbook in here.
Yes.
Yes. So we started in chapter 14, lesson 1, talking about the atom, if you guys remember that. And we talked about the matter. What do we know? What do you mean by matter? It's like everything, again, that has. Can someone answer me?
Can I answer?
Yes, Abdullah.
مثلا
Yes, Tanah, you can
مثلا
answer. I think your voice is cutting.
I said every matter is everything that have mass and value.
Yes, has mass and volume. Yes, well done. Thank you so much. So we can say it's everything that has mass and takes up space. The changing in the physical thing, يعني the physical shape, how this matter looks like, it will not really change the mass because again, the mass is conserved. So we have this word conserved, which means it's kept the same. Okay. So as you can see, for example, we have here two apples with the same mass, but one as a full shape while the other is cut into different parts. But you guys can still see that they are still the same mass, though we changed the shape of the apple. Can you see that? Everyone.
Yes.
Yes. Okay, so that means the mass again is conserved, which means it's kept the same. It doesn't change as we change the shape of the matter. Then we learned about volume, and we said that volume is the amount of space an object takes up. You guys already know that, and you know now that air is a matter that it takes up space too. That's why we fill balloons with, which means it takes up space. Volume of liquids will change the shape, but it will not change the amount. I mean, if you guys check this picture here, so you have three bottles with different shapes, but the three of them contain the same amount of water. And in the last session, you guys were like, oh, really? Doesn't look like they have the same amount of water, but they do. But because the bottles are different shapes, guys can see that the amount of space also changes. Like,
The
the
water
shape
takes
of
the
the
shape
liquid.
of the bottle.
Yes?
The water takes the shape of the container.
Yes, the water takes the shape of the container. Yes, well done. Then we learned that we can use measuring cup and graduated cylinder in order to measure the volume. Do you guys remember the measuring cup and the graduated cylinder? We had this in the last session. I hope you guys keep watching or keep following the videos uploaded on the SMS on the YouTube channel. Do you guys keep following them? Everyone?
Yes, miss.
Yes, Yusuf, for
Yes.
example. Yusuf is
Yes.
an online student. So do you follow up the videos uploaded on the YouTube?
Yes.
Okay, so we mentioned the measuring cups and graduated cylinder. You guys should know them by now. So for example, this is the graduated cylinder. This is how it looks like. We'll see it in a picture here. You guys know it. So this one is
Yes.
used to measure the volume of liquids. So we can measure the amount of space liquids take up, okay? Or we have measuring cup.
It's like it, but like it's bigger a little.
Yes, it could be big, it could be small. Most of us have in our homes. We
Kitchen.
use it a lot for baking.
Yes.
There is yes, so it's found in different shapes and different materials also. But this one is way closer to the one we use in the science lab. Okay. Okay.
Okay.
So that was it for this lesson. Then we moved. Yes.
I said okay.
Okay. Then we move to what do you mean by atom? It's the smallest particle that still carry the same characteristics of the matter. For example, the iron atom, we can talk about the hydrogen atom or oxygen atom. It's the smallest part of oxygen, but still carry its characteristics. And we learned that atoms made up of three parts with three subatomic particles. Can someone mention them to me, please?
Neutron, electronic,
Neutrons, yes.
electronics,
Electrons, not electronics, but you're close, yes.
electrons, and something else.
Okay, someone else can mention those? We have 20 people in the meeting, so I think someone can mention the three subatomic particles other than Tanahi, because he's really answering all my questions, mashallah. What about other
Protons and
people?
neutrons,
Yes, Yasin Sadat. It's nice to hear your voice.
protons, neutrons,
I
and
can't hear you. Can
electrons.
you get closer to the mic, please? And wake up a little bit? Yes.
Protons and neutrons and electrons.
Yes, protons, neutrons, and electrons. Well done. Thank you so much. Can someone mention to me what are the charges of each one? Can someone mention the charge of protons? For example, you can raise your hands if you want.
Positive.
Yes, thank you, Yasin. Thank you, Tanahi. Who else can mention that? Yes. What is the charge of proton, neutrons, and electrons? I think I will pick people randomly now. Okay, do we have Aysel with us today? Aysel?
Yes.
Yes, Aysel. So can you tell me what is the charge of any of the subatomic particles? Is it positive, negative, no charge? Protons, for example. What do you think?
It's positive.
Positive, yes. Well done. Thank you so much, Aysel. Okay, who else? We only have Tanahi and Yasin Sadat raising their hands. Malak. Malak?
Yes, miss.
Yes, Malak. Can you tell me any of the charges? Well, Aysel mentioned protons. She said that they have positive charge. What do you think about the other parts?
Neutrons don't have any charges.
Well done. Yes, neutrons don't have any charge. Thank you so much, Malak. So why don't you raise your hands? Let me see you raising your hands. Thank you so much. Thank you so much, sweetie. Okay. We can pick someone else. We have Shlok. Shlok. Do we have Shlok with us today?
Yeah, miss.
Yes, Shlok. So your friends, Aysel and Malak, mentioned the charges of protons. They said that they are positive. Neutrons have no charge. What about electrons?
Electrons are
Yes.
negative.
Negative. Well done. Thank you so much, Shlok. Yes, thank you so much.
You're
Okay,
welcome.
so that was it for this part. And of course, we said that we can't see the atoms with our naked eyes. They are invisible with the naked eyes. And then you guys learned lately about molecules. And we said molecules are made up of two or more atoms joined together, just like water molecules. Do you know water? Can someone tell me the chemical formula of the water? Please raise your hand.
The what?
The water, the chemical formula of water. Amgad?
No, I don't. H2O.
Yes, Amgad, I can't hear you.
H2O.
H2O, yes, well done. So H2O means it's made up of three atoms. One oxygen atom and two hydrogen atoms. Like the picture you guys can see here. Of course, this is not real one, but you know, they try to get it to you guys as possible, as true as possible. Okay, so let me use the pen in here. Okay, so we have here, for example, this is the oxygen atom, okay? So one oxygen atom and two hydrogen atoms, right? Like Amgid said, okay? So when we have different atoms, like here we have two hydrogen and one oxygen, three different atoms. In this case, this is not called an atom. This is not called an element. It's called a molecule. So what's a molecule again? It's when we have it's made up of two or more atoms joined together, okay? We can check something else in here. So let me get out from this one. Clear all drawings. I'm sorry, just needs some practice. Okay. So we can see other molecules here. Okay. So we have here, for example, this picture. Can you guys see the picture here? Everyone? Yes.
Yes, yes.
So we can have a molecule and a compound. What is the difference between molecule and a compound? In the molecule, we can have same atoms. For example, in this one, we have oxygen molecule. Can you see this one here?
Yes.
Yes. So we have here.
Miss, is it really red or just a color?
No, I think they just use colors to get you to, the idea of different atoms and the same atoms. I think so. Because he used red in different places, but maybe they specialize oxygen with red, but they don't really know the real colors. They don't know them. Okay, so we have again oxygen molecule. Here is made up of 2 oxygen atoms. So this one is called oxygen molecule. Water molecule is the same, like we mentioned. We have salt molecule. Can you see? It's made up of different sodium and chlorine particles or atoms, I'm sorry. So now what's a molecule again? Can someone mention to me what's a molecule again? Yes. You guys, your voice is cutting.
Can you hear me?
Made up of two or more atoms joined together.
Okay, yes, Yasin. Yes. Mamdouh, do we have Mamdouh with us today? Mamdouh? Okay, do we have Nurhan? Nurhan? Okay. So as we mentioned, yes, molecule, as Yasin said, mentioned, is made up of 2 or more atoms joined together. Here we have a close look at carbon atom. This is how it looks. Of course, this area around the atom is where electrons are found. In the center, we have the nucleus, as you guys can see, with neutrons and protons inside of it. And all the electrons are actually around or orbiting the nucleus. Carbon atom is a building block of different things. First, it's a building block of living things. Do you guys all know that we have carbon atoms in our cells? We mentioned before that one cell is made up of trillions of atoms.
Yes, you mentioned this.
Yes, so carbon is actually found in our living cells. We have diamond. Diamond is made up of carbon. And also build up coal. Do you know coal when it's under really high pressure? You guys remember this from term
Yes,
3?
coal when it's under really high pressure, it becomes diamond.
Diamond, yes, well done. We also can find it in the lead of pencils. It's not like this wood bar, like this one, the one we write with. Those are called the lead. Yes, they are also build up or contain graphite, which is or graphite, which is a soft form of carbon. And then you guys learn about nucleus. Now it's in the center of the atom and contains protons and neutrons. Then what's an element? It's made up of the same atoms. What does that mean? Like it doesn't have to contain different atoms. Okay.
I understand. Okay.
Yes, for example, the diamond is only made up of carbon atoms. So that makes a diamond an element. Okay. Coal is also made up of carbon atoms, only carbon atoms. In this case, it's also an element. Okay. So again, if we went back to the definition of an element, would
It's
say
only made of one atom.
one kind of atom, not one atom, one kind of atom. It can be made of different numbers of atoms, but they have to be from one kind, only one kind of atom. Okay?
Okay.
Okay. Unfortunately, guys, the session is almost over. Yeah, so that was it for today. You will have again another video uploaded, but I hope you can check the project video. Okay. Next time, we'll start a new lesson talking about physical changes. I know you know this one or this part. Physical changes is like the change in the shape of the atom, like melting, freezing. I mean, do you guys think water vapor is not water?
It's water, but it's changed.
Water.
It changes the steam, and it will go up in the sky. It will
Yes.
be water
Well done.
again, and it
Yes.
will be rain.
That's right. Yes, that's right. Well done, Panahi. Okay, so that's it. I will take the attendance now. If you guys have any questions, you can send to me anytime. Don't hesitate in sending to me anytime you want. Okay.
Okay.